Good afternoon, everyone. Welcome to our special presentation today, a special science snapshot with a virtual chat with a NASA engineer. We're going to be talking all about spacesuits today, and especially exciting because of the upcoming Artemis program, returning humans to the moon in just a couple of years. We're going to learn all about it, and you'll have a chance to ask some questions. So today we are live streaming on YouTube, and if you're joining us there, welcome. And we are also live at the Museum of Science. So if you're joining us from the current science and technology stage, welcome as well. We want you guys to be our drivers of this program. We're going to ask our questions of our special guests who we'll meet in just a minute. On YouTube, you can type those questions into the comment section. And at the museum, you'll have a chance to ask with a microphone when that chance comes up. So with that, I want to introduce our special guest from NASA, Stephanie Cipolla, who's been working on NASA extravehicular activities and spacesuit technology for over a decade. Stephanie, thanks for joining us.
Hi, thanks for having me. I'm really excited to be here.
So you have a little bit of an introduction of who you are and what you do, which will be great background for us as we think of some great questions for you.
Excellent. I'm really excited to be here. As Eric said, my name is Stephanie Cipolla, and I come to you today from NASA Johnson Space Center in Houston, Texas. It's a wee bit warm here today. I wish I was a little bit further north with you all. I have been at NASA for 25 years. I just had my anniversary this month, and I spent the last 17 years working in the spacewalk business, from shuttle return to flight through the end of space station assembly, space station maintenance after we retired the space shuttle. And recently I've had the chance to join the Artemis family. And now I am part of the Artemis generation, as are all of you. And we have the very amazing opportunity in our lifetime to see humanity return to the surface of the moon. And I want to talk to you about that today, about the entirety of the program, and specifically about the spacesuits and their technology that will enable humans to return to the surface of the moon. So next slide, please. It is all about the moon. If you are fortunate enough to have been alive during the Apollo years, you will remember that we had astronauts that walked on the moon. They visited the equator of the moon. And that is a very different environment from where the Artemis program is taking us, which is the South Pole. I want to show you on this next movie how different the South Pole is. As you're watching this video, notice the long, long shadows. This is a very sped up version of the lunar day and night cycle, the shadows. They are long shadows. Lunar nights are very long, up to possibly 14 days. They are not continuous because of the craters that cause all of the shape and the contours, and frankly, the scientific interest on the lunar South Pole. You can see, if you imagine yourself in just one point on this video image, that you're not going to be in the sun entirely, and you're not going to be in the shade entirely, except if you happen to be in the bottom of one of those craters. Those craters are in fact probably the most scientifically interesting part of the lunar South Pole. They are permanently shaded regions. That means ever since the moon was created, those regions have never seen sunlight. They have always been in the dark. Think about that, billions of years of darkness. And what that means is that the regolith and the chemistry of the soil down in those dark shaded regions are very different from the regions that have been exposed to the sun. And taking it back to Apollo, we expect that the science and the regolith and the other elements that are present on the South Pole of the moon are very different from what our Apollo astronauts brought back from the lunar equator. So let me talk to you on the next slide about the Artemis campaign and how we are going to get into deep space exploration. Starting at the top, we've got to get off the surface of the Earth. So first, we have our launch systems. This is the NASA array of capabilities, but we are only going back to the moon as a global community. That means that we have NASA and all of our government partnerships. We have partnerships with commercial industries in the United States economy, and we have global partnerships across the other spacefaring nations. So top left, Space Launch Systems. This is our rocket. This is what's happening on Artemis 1, hopefully in the not too distant number of weeks from here. We will have an Orion spacecraft on top. You can think of this Orion spacecraft. Do you see the cone at the top? This is the Apollo capsule times 2. We will be flying eventually 4 astronauts in the Orion configuration, possibly up to 6 as we can change what we're launching and what we have already on orbit with us. And remember that the Apollo crew only had 3. After we test out the Space Launch System and the Orion spacecraft on Artemis missions 1 and 2, we will take humans to the surface of the moon. And that's when our human landing systems come into play. These are the systems that will actually deorbit from lunar orbit, descend to the surface of the moon, taking our very valuable humans with them. And then our humans will step out onto the surface of the moon, beginning back into that exploration. These are our geologists that are going to the surface of the moon to do hardcore science. On the surface, we anticipate all types of operations. You've got to set up your capabilities, right? AT&T isn't on the surface of the moon. We've got to bring our communication system. We have to bring our power systems with us. We have to bring all of our heaters and our radiators. We have to bring our oxygen supply and our water supply and our food supplies. So some of those things we'll keep in the modules with us and carry along with the astronauts each time they visit. Many of those systems we will deploy on the surface. I'm intentionally talking fast. Sorry if I'm going a little too fast for you, because I really want to hear your questions. So top right picture here is Gateway. Gateway is going to be our jumping off point. It will be created and positioned in cislunar orbit, which is just a fancy way to say going in orbit around the moon. And it will be built up one element at a time. So in this image, you're looking at a pretty mature Gateway configuration. And on the far right, you can see where the Orion capsule has brought the astronauts and docked it to the Gateway. On the bottom, starting with the exploration ground systems and the space communications and navigation systems, SCAN, these are the systems that enable us to process the hardware to get it up and off the ground. Going into space is not something that everybody does at every street corner. So we have built dedicated facilities that have these capabilities for us. Because we are now more than 50 years into human exploration as an agency and as a country, we are benefiting from the infrastructure that the Mercury, Gemini, Apollo, Skylab, Space Shuttle, Space Station programs have all put into place. So we're not creating from scratch. We're sitting on the shoulders of giants who have done a lot of amazing work. The more we go to the moon, the more we're going to want to explore the moon. And that's when surface mobility becomes a very important part of our lunar assets. Astronauts can only walk so far, carrying their entire spacecraft on their back. So we're working toward surface mobility assets. These could be a dune buggy style, like you see here in this image, an unpressurized rover, or if you look in the far right image, there is a pressurized rover. Think about that as your recreational vehicle or your camper. And of course, spacesuits, there, my pride and joy, come to us and keep the astronauts safe so that they can leave the vehicle, take with them all of the life support that they need to be safe on the lunar surface and explore. They're not going out just to walk around. They're going out to do science, to do geology, and to build an Artemis base camp. The Artemis base camp is what we're calling the initial configuration of our assets on the moon. It is by far the finish line for us. It's a word that we're using to describe a compilation of our first collection of assets that we feel are really going to enable science. Next slide, Patricia. Thank you. So when we go to the moon, we're going to do science. I've said that already. So the Artemis 3 Science Definition Team Report has out there, and it has outlined our science goals. All of this feeds back into everything I just described to you. We are going to the moon to do science. So what does that mean? Well, we need spacesuits that are capable of kneeling and bending and squatting, and then standing back up afterwards and scooping up regolith of different types. Are we going to do core samples? Are we going to collect rocks? Are we going to scoop sand? How sharp is that sand? All of this comes from the science objectives, and it feeds into requirements that define the requirements for the systems that we need to be successful on the moon. Next slide. To do that, we need new technologies that didn't exist when we went in Apollo, and technologies that we haven't needed living in low Earth orbit as we have for the last 40 plus years. These are our technology objectives. In situ resource utilization. That means we're going to go to the moon and we're going to use what we find there to live, to survive. We need surface power. What does that mean? Are we going to use solar? Are we going to use fission? Are we going to use nuclear? These are all questions that we haven't found the answers out. And we're engaging with industry and academia and other elements of the government to develop these technologies. Dust mitigation is a really important one that I'll talk about a little bit more on our spacesuit pages, as is this extreme environment and the difficulty of getting there. Next slide. Okay, so what does this campaign look like? So if you start on the left, of course, here we are on our favorite spaceship, Mother Earth, and we will be taking astronauts in Artemis 1 to the moon, first time in the 21st century. I'm sorry, I said that wrong, apologies. Artemis 1 is the spacecraft. Artemis 2 is the humans. And then we start building up the gateway. And then Artemis 3 through 5 is when we start building up our Artemis base camp. You can see on the lunar surface here, kind of across the bottom of the slide, that we want bots before boots. Being a combined infrastructure of robotic exploration and human exploration makes it safer and more efficient and more cost-effective for us to put humans on the moon. If you're a lover of robots, you might be in the camp of saying, why even bother sending humans? It's so risky. The robots can do everything. And I challenge you in that thought, because humans bring human ingenuity. And we have some really incredible engineers on the surface that are developing our systems, but you just can't beat someone in that location, in that moment, looking at a problem and solving it with their clever brain. And so that's why we have this really wonderful partnership between the robots that go first to do some of that early exploration, and then the humans going to the destinations that we're now so much smarter about because we did send those robots. Next slide. All right, here's my favorite, astronauts and spacesuits. So on the left side of your screen, you're looking at a concept image of a lunar surface spacesuit. On the right-hand side of the slide, you are looking at the current exploration, the current extravehicular activity mobility unit. At NASA, we really love our acronym, so we call that our EMU. You can call it our spacesuit. What you'll notice in this image is that on space station on the right, that astronaut is in microgravity. And that's important because they're not using their feet to get from place to place. They're also in low Earth orbit. So there's no dust. There's no need to kneel. There's no friction from unexplored surfaces. Take it over to the left and look at our lunar surface suit and think about the differences. One, they're walking. Well, that means that they need dedicated boots. They need a lower torso or a pants assembly that enables that walking. To stay alive in a vacuum, which is what we have in low Earth orbit and on the surface of the moon, you have to bring everything with you. So we pressurize spacesuits, but imagine the difficulty of walking around in a balloon. Even if that balloon is contoured and shaped like a general human body, if you're just in a soft goods suit, right, just all fabric, and you blow it up like a balloon, it's really hard to move. Every time you walk, every time you move your arms, you are pushing against the force of that balloon. Even if we only pressurize that balloon to say 4 pounds per square inch, you're still fighting the balloon. So getting to the surface of the moon means a spacesuit that has mobility by design in its upper torso, in the arms and the hands and the elbows, and in the hips and the waist and the knees and the ankles, because walking is so much more important when you're in a gravity environment. The good news for us is that it is a vacuum in both destinations. So the life support systems can be very, very, very similar. And frankly, the life support system is probably 80% of the hard part of keeping a human alive in space. The other thing I want to point out here on the left image is that this astronaut is holding a regolith sample, a rock, right? A moon rock. Now, the moon has never, ever had an atmosphere. So unlike the sand that you find at the beach or on your hike in your favorite mountain or trail, it's not smooth. It's sharp. In fact, it's glass-like shards. So a spacesuit has to enable an astronaut to touch these shards and protect them from the shards. Think about all the times that you're out hiking. You're down on your hands and your knees and you're exploring the world around you. And we need a spacesuit that can do that for our astronauts. Next slide. And so we're moving into a new paradigm, we, the spacesuit community. NASA has been doing commercial partnerships and commercial service contracts for quite a few years. Look at our launch to orbit for our satellite industry. Look at our commercial cargo and our commercial crew programs. These other NASA teams have worked with industry partners in a commercial services paradigm so that the technology and the operations are not being done by NASA. That's because NASA, by charter, is supposed to do the really hard R&D and then hand all of that over in technology transfer to US industry and enable commercialization. So we're very pleased to have just awarded a contract for the next generation spacesuits. You can see here the two companies and their partnerships that we have awarded this contract to, Collins Aerospace on the top right and Axiom Space on the left. These companies will be building our next generation spacesuits, the spacesuits that we need on the space station, because space station has quite a lot of years left in it, and our current EMU is over 40 years old, so it's getting a little bit tired, and the spacesuits that we need to go to the moon and beyond. You see also here in the lower right-hand corner that we have been doing a good deal of work at NASA, doing this development work, and we're taking this technology and we're enabling industry to be successful, and that is our partnership. We're not saying adios, good luck, we'll see you on the surface. We are hand in hand partnering with these new companies, and there are elements that NASA will retain its responsibility for. Next slide. When we get there, we're going to plant a flag, and I hope there are many proud Americans in the audience with me today. And I think my next slide is my wrap-up slide. I talked too long. I want to get to questions. So these are future elements. I talked about this already, lunar terrain vehicle. This is our unpressurized mobility asset. The pressurized rover, this is your camper, and then habitats, because you can't always be on a spacewalk. Sometimes you have to come inside and take a rest and eat some dinner. Next slide. All right, what questions do you have for me?
All right, thanks so much, Stephanie. It's so amazing to hear about this program that's been going on for so long, and we're finally getting close to that first launch. So people are getting excited about it. I know I'm excited. And the first question we have, I'm sure you get this all the time. It probably is the most common question we get about anytime people are in space. What happens when the astronauts have to go to the bathroom when they're in their spacesuit and they're on one of their long excursions, couple hours?
You know what? I have heard that question before. And the answer is they wear a diaper. Imagine living in a spacesuit for 8 hours. Personally, I can't go on a car ride for 8 hours without a little bio break, and neither can the astronauts. So they do take a water bottle. In fact, they wear it as like a front-facing backpack. So they have water to drink during their spacesuit to keep them hydrated and keep their bodies performing high. And of course, what goes in must come out, and that's what the diaper's for. We do, as an interesting aside, we do take care of the smells as part of the breathing that's in the life support system. So not only does our life support system in a spacesuit wash out the carbon dioxide that the astronauts exhale with every breath, but it also has an air filter in there to take care of humidity and aromas.
All right, let's throw it to the stage. Becca, do we have any questions from the museum in person? All right, looks like maybe we're still waiting on some people to come up and ask questions. Let's move on to the next one. We'll come back to them. Someone asked about the EVA pod in 2001: A Space Odyssey. Have you seen that movie, Stephanie? So it's kind of like a cross between what you described as like the camper on the moon, a pressurized vehicle, but it's in space, and it's almost like a spacesuit that is the size of a room that you can move around. Is that something that's realistic? Is that something, it's not designed now, but you're still waiting on?
So anything is possible, right?
Hey, Eric, we got one, Eric.
All right, can I come to it after I finish answering this one?
Kind of like,
okay.
I think we're on a delay.
Oh, I got it. Okay. So you can imagine a bubble, maybe that has some robotic arms that an inside astronaut could be wearing, and they take this mini spacecraft away from their home spacecraft and do a little bit of a jet propulsion, and they walk around that way. That's totally possible. The question becomes, what do you need to get the job done? And getting off the surface of the Earth and all the way to any other planet, including the surface of the moon, costs rocket fuel. So we make really tough decisions and really intentional decisions about what we want to take with us. So if there becomes a need for this type of a space pod, if I think if I understand it right, Eric, then sure, we can do it. Today, it's not part of our plans.
Sounds like it's just easier to have the spacesuit itself be able to, pop around on the outside of the space station than it is to build a whole giant spaceship within a spaceship. So
exactly. It's much more intuitive for the human operator.
All right, we got a question about the spacesuits and how they fit. Are they custom made for each astronaut? Are they sizes? I guess we want to know about the spacesuits that are happening now. And then as we want more and more people on the surface, as we're getting not, a couple people in space at a time, but maybe a couple dozen on the moon, are they each going to have their own, or is it going to be kind of small, medium, large?
Right. Excellent question. So today, the answer is both. We have spacesuits, kind of like a little spacesuit closet on the space station. Today, we have 3 on orbit. In addition to the main body of the spacesuit, we call that the upper torso. And then the lower torso, our spacesuit today, we put on like a pair of pants and a shirt. We have spare arms and spare legs. Every human is different. Some people have really long arms and some people have T-Rex arms, right? And so we swap out the arms and the legs to fit. Even inside each size of each arm, you can do some custom sizing. We've got a fantastic drawstring technology on the inside that even if you're a medium upper arm, you might need it to be a medium upper arm half shrunk up, right? Because you're not quite short enough to switch to a small arm, but you're not a full medium. So we can customize within our existing sizes. Our closet on orbit is medium, large, extra large. But we make custom gloves because hands are so different. And when you're in microgravity, your hands are your feet and your hands are your workers, right? So everything you do in microgravity relies on your hands. And that's the reason it's worth the time and the energy to do a custom glove for every astronaut. For exploration, we have extended the breadth of humans. We intend to fit spacesuits from first female percentile to 99th percentile US male. This is a lot of different people, but we're not putting giant space stations on the surface of the moon. So what we are challenged with is how do you fit a broader range population without going like crazy on the logistics, needing your own like closet dedicated to spacesuits. And so we've got some really clever designs that we've tested, but the intent will be for the commercial providers to make sure that they have the right size suit for the right size astronaut at the right time.
Good to know.
It's a bit of a Tetris.
All right, we have a question from our in-person crowd at the museum today. What material is the spacesuit made out of? I mean, I guess there's lots of materials, but I guess one of the most common materials. And can you buy it? Is there anything that you can actually take home and make a shirt out of the same fabric that goes into the spacesuits that we make?
I've never tried that, so I can't answer that part of the question. The spacesuit is made up of a lot of materials because the spacesuit has a lot of functions. It is your balloon. So on the inside, we have a pressure layer. We have Kevlar, we have orthofabric, we have polyurethanes, we have multi-layer insulation, and all of these layers stack up because the spacesuit pressure garment has to protect for pressure. It has to, the white outer layer is the orthofabric, so that's your first radiator where the sun comes in and the heat from the sun reflects, just like wearing a white shirt on a hot summer day. You feel better than if you're on a black shirt absorbing all that heat. Astronauts tend to get hot on spacewalks because they're working, so we don't often need to turn the heaters on for them. They almost always turn up their air conditioning inside the spacesuit. And in fact, it's not air conditioning, it's water cooling. They wear a great big jumpsuit that is lined with miles of tubing, and through the tubing, they run water that is they're carrying on their life support backpack. And they have a control dial right on the front of their spacesuit that they can turn the temperature up or turn the temperature down, depending on how they feel, whether in the sun, how hard they're working. So it's all very adjustable at every opportunity they need it. Going back to the layers of the spacesuit, in some of the thicker spots, the spacesuit is made up of 13 layers of material. In the hand, where we need a lot of extra mobility, we have a couple different types of material. We use a material called turtle skin because it's very cut resistant. And then we use vulcanized rubber because it's very cut resistant. But because the hand has to be so mobile, there are only 5 layers in that part of the hand. So
I guess if you wanted to go to the fabric store and make your own spacesuit, you'd have to go to a pretty specialized fabric store.
You'd have to go to a pretty specialized store.
Still probably struggle to make anything that's going to work.
Maybe so, but the majority of the spacesuit, the soft goods part of it, is stitched by hand.
Wow.
Yeah.
All right, we have a couple more minutes. If you have any questions, type them into our YouTube chat. If you're at the museum in our audience now, you can go ahead and let our educator know, and they will relay our questions to you. Stephanie, we have a question about the spacesuit to go to the moon, and looking to the future, the spacesuits that we're going to use on Mars. Are they going to be pretty similar? Are we going to need to do a couple of modifications, or do we need to start from scratch when we think about astronauts walking around on Mars?
Location, location, location. So to answer that question, you have to think about the differences between the moon and Mars. Both have gravity. Okay, check. That's a nice similarity. So they both need to walk. Check. They both have dusty environments. Check. Is the dust the same? No, not really, because Mars has an atmosphere. So now you just got to another part of the environment. The moon is a vacuum. It's a hard vacuum environment. On Mars, we have a small atmosphere that includes carbon dioxide. So that changes right there my life support system, the element of it that is keeping my oxygen breathable for the astronaut inside. I need a new technology because I can't rely on my vacuum to get rid of the CO2 when I go to Mars, because there is no vacuum there. Mars is a very different temperature. It's about 70, balmy, kind of a really fun environment until it's not. And then it's a giant dust storm because it has this atmosphere. And with the atmosphere, just like we have on Earth, comes weather. So that part will be very different. The gravity on the moon is 1/6 approximately that as the gravity on Earth. So you remember the imagery from Apollo where the astronauts just seem to be like bouncing and bunny hopping and moving with great ease. When you get to Mars, the gravity is a little bit more intense. It's 1/3 that of the gravity of Earth. So now your spacesuit that maybe weighs 300 pounds, but on the moon, because it's 1/6 is really only about 50 pounds. When you get to Mars, now it's 100 pounds. And think about taking a 6-hour hike with a 100-pound backpack. So reducing the weight of every component and every bearing and every material is very much on the minds of our design engineers. So the suits will be similar, but not exact.
All right, we've got time for just one more question. And I think we'll end by asking you specifically, how did you get into this? How did you become spacesuit focused engineer working on this kind of program? We have a lot of young people in the audience. How do you get into that? What do you study in school, and how specifically did you end up working there?
I loved math and science, and I had a fantastic 7th grade teacher. And he said to me, you should be an engineer because you like math and science, and frankly, because you're a woman. And I said, cool, I'm going to be an engineer, not the kind that drives a train, but I don't know what an engineer is. So somewhere along the way, I went to an excellent camp in high school. I grew up in the Detroit area, so I went to the University of Michigan for a summer camp for high school girls, and they introduced us to every college within their school of engineering. And in that 1-week camp, we got to see what the coursework would be like and what the job would be like. So from there, I decided I'm either going to be an aerospace engineer because I love space and it's cool, or I'm going to be a biomedical engineer because making false artificial limbs is amazing and cool and how awesome for humanity. So that got me to high school graduation. I found an incredible school called Embry-Riddle Aeronautical University in Daytona Beach, Florida. It is a school that is all about airplanes and space, and it just was exciting to me. So from Embry-Riddle, I moved to Houston with a degree in spacecraft design. I'm an engineering physics major. And I taught astronauts as my very first job here at Johnson Space Center. I did that for about 7 years. I went to graduate school in France. I have a master's of space studies from the International Space University. I came back from that degree and went back into my training job, and it was awesome, but I had a little bit of the been there, done that problem. So I looked for something new, and that took me into spacewalking business and project management, and it's been my home for the last 17 years.
Well, that's awesome. Stephanie, thanks so much for telling us all about the Artemis program, your role in it. We're getting super excited for the launch of the first mission coming up as soon as next month. We'll definitely be live streaming at the museum, watching along, and good luck with everything in terms of getting the first humans back to the moon in 50 years. Hopefully pretty soon. Good. All right, thank you to our audiences as well. I'm sorry we couldn't get to every single one of your questions, but that's all the time we have for today. Be sure to follow us on social media for all of the updates on the Artemis missions and our live streams as we talk to more engineers and watch the missions unfold and humans get back to Mars. So thanks. Enjoy the rest of your day at the museum. Thanks for joining us, and we'll see you next time.